All right, and go to the textbook, the ebook. Second here. Oops, looks like I have to re-sign in. Just give me a second here. Yes. All right, just give me a second to re-sign in. Almost there. Okay. So we'll get back to chapter 7. And here we go. This is where we're supposed to be. Section 7.6 exercises. I have a few of them that I wanted to go through with you today. First one would be 7.71. 7.71. So here we're dealing with strictly with the standard normal curve. Remember, the standard normal curve has a mean of 0 and a standard deviation of 1. All right, and we want to find the area under the curve, this curve, between negative 2.22 and positive 0.53. Now, the curve itself is a bell-shaped curve, and the mean, median, and mode will all be 0 for the z standard normal curve, because that's what the mean is. The mean is 0. So right in the middle will be 0. And then to the left would be negative z's, and to the right of it would be positive z's. Okay, so negative 2.22 is going to be to the left of the mean. 0.53 will be to the right of the mean. So again, as I mentioned to you last time, it would be beneficial for you to have pencil and paper with you when you do either homework or a quiz or tests. And when you have a problem like this, draw a little curve, and it'll help you visualize what you're trying to find. So it's the area under the bell-shaped curve between negative 2.22, positive 0.53. Okay, so let's see. So let's go to the calculator. Go to the screen. Now, standard normal is a normal curve. It's that special normal curve with a mean of 0, standard deviation of 1. So to find any probabilities or areas under the curve, we're going to be using normal CDF. All right. So to find those probabilities areas, that's what we're going to use. Again, with your 83 calculators, you'll just see normal CDF with an open parentheses. Know that this is the order that you put the numbers in. We'll have the lower endpoint of the interval, the first number, then a comma, upper number of the interval, then comma the mean, comma the standard deviation. So you have to type all those things in, close the parentheses, and hit enter. All the rest of you, you'll get a screen that looks like this. Now it's between negative 2.22, so that's our lower part of the interval. Remember, where the negative sign is here, we don't use the subtraction sign. Negative 2.22. Scroll down to the upper endpoint, 0.53. And it's already defaulted to the mean of 0, standard deviation of 1, so that's correct. Scroll down to paste, hit enter. This is what it should look like if you typed it in with your 83 calculator. Hit enter again, and there's the answer. If I ask you to round the probability to 4 decimal places, 0.6887. Okay, that's the area under the curve. That's the probability of a z random variable, a standard normal random variable, between negative 2.22 and 0.53. Questions about that? Okay. Go to the next part of this question. The area under the curve between negative 1 and 1. Now, you may be thinking about what you might have learned in the past. And if you remember, there was something called the empirical rule that you learned quite a bit in the past. And you remember that between negative 1 standard deviations and positive 1 standard deviations from the mean, the area is about 68%. Okay? And that's what the Z curve represents, the number of standard deviations from the mean. We would expect an answer between around 68% or 0.68. It's going to be a little bit slightly different because calculator is giving you an exact answer. Let's try it out. Okay, we'll go back to where we were, normal CDF. This time we're going to put negative 1. Remember the negative signs down here, negative 1, positive 1. Again, the mean and standard deviation remain the same because it's a standard normal. Hit enter. And look here, it's 0.68268948. So rounding to 4 decimal places, it's 0.6827. Pretty close to that 68% that the empirical rule said it would be. All right. Any questions about that? This is the exact answer. All right. And then let's look at the last one. It says between negative 4 and positive 4. The standard normal. So we'll get again. I won't go back to the ebook. That's what it's saying between negative 4 and positive 4. We would expect almost 100% of the area of the curve to be between those two values. All right. Well, let's see what our calculator gives us. Negative 4 and positive 4. Yeah. Say practically 100%, 99.99%, the area under the curve, right? So when we get that far away from the mean, almost the entire curve is between those two values. All right, everybody good with that? All right, now let's look at 7.75, same section, exercise 7.75. Scroll down to that. There we go. Again, standard normal. Mean of 0, standard deviation of 1. Again, your ebook and your textbook has answers here, so you should try these without looking at the answers, obviously, right? So that you know how to do the calculator steps. Otherwise, you'd have to use tables in the book, which is not very good. Now, notice here the first one says Z is between less than or equal to negative 0.55 and greater than or equal to negative 0.77. Notice the equal signs here don't matter. We're going to get the same answer whether we have an equal sign here or we don't. All right, so it doesn't matter whether it's equal sign. And the reason is because Z is a continuous random variable. The probability that Z is equal to a particular value is always 0. All right, so again, we'll practice this with our calculator. 7.75a. Do that first. Let's clear the screen. And normal CDF. All right, in this problem, the lower endpoint is negative 0.77. Negative 0.77. Again, to the left of the mean. Notice the right endpoint is also to the left of the mean. All right, the next, the upper endpoint is also to the left of the mean. It's negative 0.55. Scroll all the way down, hit enter. As you do with the 83 calculator, that's what you would enter. And it's around 7%, right? 0.0705, or more than 7% of the area is between those two values. The next one, let's take a look at the next problem. Probability that z is greater than 2, So 2 is to the right of 0, so it's going to be a tail question, right tail question. Probability z is greater than 2 would be the area to the right of 2. All right, back. Calculator. Again. Normal distribution again. Now, because it's greater than, it's a right tail problem, the lower endpoint will be 2. We're going to type in 2 here for the lower endpoint. Now, the upper endpoint is positive infinity. It goes all the way out, so we pick a number that's significantly greater than the mean and standard deviation here. In this case, we're going to pick 1,000. So that's definitely significantly better. But you could pick, 50, 100. It probably all give you about the same answer. 0.02275. Rounding it to 4 decimal places, 0.0228 would be the probability or the area of the curve greater than 2. Okay. C. Probability that z is greater than or equal to negative 3.38. Now that negative 3.38 is to the left of 0. It's asking for the probability being greater than that. So we know it's going to be a large probability, right? A good portion of that curve, probably well over 90% of the curve will be to the right of negative 3.38. So let's stop sharing, go to the calculator, and look at that question there. All right, so again, right tail, right? The lower endpoint would be negative 3.38, negative 3.38. You can keep the upper endpoint as 1,000 because it's a right tail question. You can see pretty much the whole curve, almost the whole curve, is to the right of negative 3.38, 0.9996. The last one is the probability. Let's go to the calculator again. Or the book again, I'm sorry, the book. And it's asking for the probability that z is less than 4.98. 4.98 is way to the right. Practically the whole curve is going to be to the left of that value, but let's just double check that. Back to the calculator. Less than means that the number that we're given, 4.98, is the right tail. The upper tail, and the lower tail, of course, will be negative infinity. So we want to pick a number that's pretty small. So we're going to pick negative 1,000 here. And you can pick whatever you want that's significantly lower than 0. And then the upper tail would be our number 4.98. And again, we expect almost 100% of the curve to the left of that value. Yeah, pretty much the whole curve, right? Look at all those 9s there. Almost the entire curve. Okay, any questions about how to find these? Now, I want to show you one question in 7.77. We're going to go to 7.77 just to show you one of them, which looks a little different than the ones we've done so far. Let's go down to 7.77. And I'm interested in D. Just the probability that z is greater than negative 1.5 or Z is greater than 2.5. Now, if you drew this curve, here, it says greater than, Z is greater than, sorry, this looks different than what I'm looking at in the book. This is incorrect the way it's typed in here. It should say Z is less than negative 1.5. That's what the book says. It says greater than here. I don't know if I can edit it. But I can't. So let me just tell you, this is wrong in the ebook. It should say probability that Z is less than, not greater than, negative 1.5, or Z is greater than 2.5. All right, so make the correction. If you're taking notes, that D is incorrect here. It should say less than negative 1.5. All right, so let's try this with our calculator in the way it should be. Now, let's think about it for a minute. If Z is less than negative 1.5, that means now 1.5 is to the left of 0. And this would be a left tail, right? If this would say negative here, or excuse me, less than. Greater than here, 2.5, 2.5 is to the right of 0, and this would be the right tail. So what we're being asked to do is the probability of a left tail or a right tail. Do those two probabilities areas intersect? No, right? They're completely separate from each other, completely separate, which means they are mutually exclusive. Remember that term we used in chapter 6, mutually exclusive. That means when we use the word or, we simply add their probabilities. So what we need to do is find the probability of the first one and add the probability of the second one. So let's go to our calculator and do that. All right, clear the screen. Now, you could do this all in one step, by the way. Show you how to do it. Let's do the first probability first. It says the probability that Z is less than negative 1.5. All right, normal CDF again. Now, it says less than, right? That means left tail. That means we're going to have negative 1,000 lower, and then we're going to have negative 1.5 upper. All right, so we want to know the probability that Z is less than negative 1.5. We'll scroll down, hit enter. Now, at this point here, if you were going to do this as all in one line, instead of hitting enter here, you could hit the plus key, because you're going to add the other probability. All right, so I'll hit the plus key here. Now you could hit the enter key and then hit plus. It doesn't matter which way you do it. But I'm going to hit the plus key here because I'm going to do it all in one step. And then I'm going to do second, go back to normal CDF. All right, we're going to do the second one. That's the probability that Z is greater than 2.5. So greater, that means right tail. 2.5 is our lower endpoint of that interval. I'm going to use positive 1,000 for the upper. Scroll down, enter. Now, here's what you see for the second one, and notice it's going to be added to the first normal CDF. So when I hit enter, I'm going to get the sum of both of those. All right. And there's the answer for the entire problem. Probability that Z is less than negative 1.5 or Z is greater than 2.5 is 0.073, or 7.3% of the area under the curve. It's either in that left tail or in that right tail. So you add both of them together. All right, I wanted to show you that because that looks different than the other problems that we've been working on. Questions about that one? Note, covered that. All right, let's go to 7.79 now. We're looking at problems where we're going to be working in reverse. Remember when we talked about working in reverse? Right, so 7 here. 779. All right. So they put to determine the value z star. Why do they call it z star? Because it's a value of z that we're trying to find. So because they want to differentiate it from the letter z, they call it z star. All right, but it's basically a value of z such that, use the word such that, it separates the largest 3% of all z values from the other values. So the largest 3% of all z values. The largest 3% would be the right tail, wouldn't it? The largest 3%. It would be a right tail that has 3% of the area when we use the word largest here. Now they say that separates that from all the other values. What they're really saying is what is the smallest z such that 3% of the area is to the right of it. All right, that's what they're saying. Again, you draw a curve and then you have your 3% to the right of the z and you call it z star, and then you're trying to find that z where the area to the right is 0.03. 0.03 is the equivalent of 3%. All right, let's go to the calculator. Now, because we are given an area or probability, we're working in reverse now. We're trying to find that value of z, where the area to the right of it is 0.03. This is where we're going to use that special inverse operation called inverse normal. Go down to 3, hit enter. Now remember, except for those of you who may have some special calculators where they give you the option of saying the area is to the left, in the middle, or to the right. Most of you don't have that. I don't have it here either. But what area do we use here? It's the area to the left. That's what you have to type in here. Not the area necessarily that's given in the problem, but the area to the left of that z value. Now, if we know that the area to the right, because it says largest 3%, the area to the right is 0.03, can somebody tell me what the area to the left is? Okay, come on. You should be able to do this.
Are you talking about the you talking about letter A? Would it be 97?
97. Now you don't type in 97. You type in 0.97. You type it as the proportion. All right, that's very important. The calculator is not asking for the percentage of the area. They're asking for the proportion or decimal. So you type in 0.97 here. All right, is everybody clear on that? 0.97. Now, if you didn't want to do the math, you could say 1 minus 0.03 because 0.03 is to the right, 1 minus 0.03 is to the left. All right, I'm going to type in 0.97 because I can do the mental math. Now, the mean is, this is a standard normal. The mean is 0, standard deviation is 1. So we're going to get a z when we calculate this. Now, for those of you with the 83 calculator, this is what you would type in. You would, you choose inverse normal and it would open up a set of parentheses, and then the left endpoint goes in first, the left area, the area to the left, goes in first as a proportion, comma, the mean, comma, the standard deviation, close parentheses. All right. What you're given here is that z, 1.88. That's the z value where 3% of the area under the curve is to the right of that. All right. The area to the right of z is equal to 1.88 is 3% or 0.03. That's what we're trying to find. This is the reverse operation. That's why they call it inverse. Okay, let's look at the next one. All right, let's look at B. Separates the largest 1% of all z values from the others. Well, this is the same question as the previous one, except we're going to change the area to the right to 0.01. Now, I know a lot of students, when they do mental math here, they might put, they might think 1% is 0.1. All right. So to avoid that arithmetic error, I would suggest to you who have those types of, who make those types of errors, to use 1 minus 0.01 as the area to the left. All right. Or use your calculator and divide this by, what do you divide this 1 by? 100, right? To convert a percentage to a decimal, you divide by 100. That means 1% is 0.01. That's the area to the right. That's the largest 1%. So we want to use the area to the left. So it's the same problem as the previous one, except the area is different. Then we'll go to inverse normal. This time I'll just type in 1 minus 0.01. 0.01 is 1%. So the area to the right is 1%. The area to the left is 99%. And I'm typing it in this way this time. Notice now that the z is 2.326. You round to 3 decimal points. All right. So what we're saying is that the area to the right of z is equal to 2.326 is 0.01 or 1%. 1% of the area is to the right of that number. Any questions about that?
So it doesn't matter if we do like 1 minus 0.01 or we actually put like 0.99.
Right. Right. In the first case, we're letting the calculator do the arithmetic. The second case, you're doing the arithmetic. See what I'm saying? Calculator will do what you instruct it to do. So put in the number, that's great. If you want the calculator to figure it out, you can type in 1 minus.
So either way, we get the same result.
Absolutely get the same result.
Okay.
I would pity the calculator does not give you the same result. Right? I mean, it should give you the same result. All right, let's look at the second one. We want to find the z that separates the smallest 4% of all z values. The smallest must be the left tail, correct? 4% left tail. So the area to the left is going to be 0.04. That's what it's saying here. All right, and then let's just show you this one example here. We can move on because the other one looks exactly the same as this one. So again, inverse normal. Now, in this case, they give you the area to the left, don't they? They say the smallest, the smallest 4%. So we type in just 0.04. All right, because remember the area that the calculator is looking for is the area to the left. So a left tail is always area to the left. So if it's a left tail, you just type it directly in. If it's a right tail, you do 1 minus to get the area to the left. All right, get the idea? But you have to know both of those things. So this is saying here, and this makes sense, the area to the left of negative 1.75 is 4% of the area under the curve, or 0.04. You could say the probability of z being less than negative 1.75 is 0.04. Okay? Everybody good with that? The next problem, it says 10%. I mean, it's the same thing as this one. So you don't need to repeat the process. It's the same process. All right. Well, let's go on to some other fun activities. I'm sure you're all having a great deal of fun today. All right, let's look at 81. Number 81. Now we're going to talk a little bit about percentiles. Remember what a percentile is. Percentile is the percentage of data that's less than that value, less than or equal to that value, right? Doesn't that make sense that when we talk about area to the left, we're really talking that value of z is that percentile. So for example, the previous question, when we found negative 1.75 and we said the area to the left is 0.04, we convert that 0.04 to a percentage, it's 4%. That negative 1.75 is the 4th percentile. Because the 4 represents what? The percentage of the distribution that's less than that value. So when we're that area, that another name for a percentile is cumulative area. It's the area to the left, cumulative area. All right. So when we don't get fooled when you see percentile, it means exactly the same thing as area to the left. Okay. What they're asking for is that particular value of z or x, depending what's being asked, but that particular value of z, where the area to the left is that percentile. So, for example, here, it says the probability that z is less than 0.44 is 0.67. That means that the 0.44 is the 67th percentile. 67% of the area is to the left. 67% of the probability distribution is to the left. All right, get the idea? Cumulative area, percentile, mean, and area to the left mean all the same thing. So please don't get this wrong when I test you on it. I'm telling you right now what it is. All right, I'm giving you the definition of this. But I want you to be able to read words like percentile and be able to interpret it. Interpret it. Interpret it. All right. Interpret what percentile means. What does it mean? It means area to the left. So if you're being asked to find a percentile, you use inverse normal because the percentile itself is giving you the area to the left. Get the idea? So like part A here, the 91st percentile. Well, the area to the left is 0.91. Remember, the 91 is representing a percentage, so we divide by 100. We get our decimal version of it, 0.91. That's the area to the left. So to find the 91st percentile, again, inverse normal. You're being given a probability and you're being asked to find the value, right? 91st percentile for Z, you just type in 0.191 here. It's the area to the left. Percentiles should be easy questions if you understand the definition of it. That's the whole key here. So the 90 for Z's, the 91st percentile is 1.34. Maybe if you wanted to round to the 3 decimal point, you might put a 1 there, 1.341. But this whole thing is the 91st percentile for Z's. Okay. What if I ask you, find the Z that is the lower quartile, the first quartile? What would you do? Let's see how good you are with what I've said so far. How, if you have absorbed what I've said to you so far. I want you to find the Z that corresponds to the lower quartile. How do you convert a quartile to a percentile? Come on, somebody must know this, please. Remember when we did box plots? What percentage of the data is less than the lower quartile?
Would be 25%.
That's right. So isn't that the 25th percentile? You agree?
Yes.
Yes. So it's the same question. If I ask you to find the Z that corresponds to the 25th percentile, you're basically being asked to find the area, the Z that corresponds to the area to the left of 0.25. Okay? Inverse normal gives you that answer. You just type in 0.25 here. There it is, negative 0.6745 if you round it to the 4 decimal places. Can somebody tell me what the Z would be for the 75th percentile? Without doing any arithmetic, just staring at the screen here, stare at it. What would be the 75th percentile? What Z corresponds to that? What do you think? Think about symmetry.
Wouldn't it be that same answer, just positive?
That's it. Point positive, this number. Right? That makes sense, right? Because the 75th percentile means that 25% of the distribution is greater than that, doesn't it? If 75% is lower, 25% is greater. And because of symmetry, it would be located in the same location, the mirror image location along the Z-axis, right? So this would be the 7, and let's just try it out. Let's just see if we get that, right? We should get exactly that answer. So again, the upper quartile we're now talking about, the 75th percentile, we're going to type in 0.75. See? And just to really test if you know things pretty well, what would be the 9th percentile? Again, looking at the screen here, what is the 9th percentile? Don't you think I'm sort of asking the same type of question here? Think about it. The 91st percentile means what? 9% is greater than that value. 91% is lower. The 9th percentile means 9% is lower. So the 91st percentile has a right tail of 9%. The 9th percentile has a left tail of 9%. I gave you enough of a hint. What must be the Z corresponding to the 9th percentile?
The opposite of 1.34075.
That's right. Negative this number. See? Symmetry. And let's just test it out to see if that's true. Okay? I want you to be thinking in these terms, okay? Because that means you're understanding it as opposed to just mimicking what I'm doing. You don't want to just mimic. To me, you're not learning anything if you just mimic. See? It's the negative of that first answer. And finally, what is the Z? What is the Z corresponding to the 50th percentile or the median? What must it be? I expected an immediate response for that one. What is the Z corresponding to the median or the 50th percentile?
0.
0. Because the median is equal to what? The mean, right? That's what. 0's in smack in the middle. That's your 50th percentile. That's your median. 0 for the Z. Okay. Now, let me just, I think we have plenty of time here. Let's do something else. Let's come up, I'm going to come up with a, let's say we're giving a test. We'll call any type of test. And let's say the mean for the test is 80. And the standard deviation is 15. All right. So you can write this down. The mean is 80. And suppose the tests are normally distributed. We're going to call it normally distributed with a mean of 80 and a standard deviation of 15. Let's try to do some areas and let's try to do some, well, I say probabilities, same thing as areas. And let's try to find some percentiles with that also. All right. So let's practice that too. So what if I wanted to know the probability that x, now we're going to call this x. This random variable is going to be a normal x, is going to be a normal distribution with a mean of 80, standard deviation of 15. We're not in the standard normal curve anymore. We have another type of normal curve, 80, 15. 80 mean, 15 standard deviation. And I want to know the probability that x is greater than 85. All right, x is greater than 85. So you're being asked to find the probability that x is greater than 85. So again, you're going to use normal CDF because you're being asked to find an area or probability. This is a greater than problem. This is a tail problem. So it's a right tail, right? Greater than is right tail. So the lower endpoint of a right tail problem is going to be the 85. And then where we want to pick a number big enough, so the area to the right of it is, for the upper tail I'm talking about, we want to pick a number group big enough so that the area to the right of it is practically 0. Now, know that we found out before that 4 standard deviations bigger than the mean, the area to the right is practically 0, correct? So 4 standard deviations, if the standard deviation is equal to 15, 4 of those is 60. 4 times 15 is 60. And if you add that to 80, you get 140. So basically, if you picked 140 here or some number bigger, you'd be safe. So if you picked 1,000, you're safe. All right? Anything bigger than 140, you're probably safe to pick, and you'll get the right answer. So I'll pick 1,000, definitely bigger than 140. Now, am I going to leave the mean as 0? Anybody? Am I going to put 0 for the mean here?
No.
No. What are you going to put in there?
80.
80, that's right. And then for standard deviation, am I going to leave 1 in there or am I going to put something else in there?
You're gonna put something else?
What number did I give you for it? Did you write it down?
You gave us
15, yeah, 15. This is the problem. This is the probability that x, a normal random variable with a mean of 80 and a standard deviation of 15, probability of x is greater than 85. The way you would type it in for your 83 calculator, and there's your answer, 0.3694, rounded to 4 decimal points. Okay? We could also say, since this is a word type problem, right? We're saying, all right, this is a test, and people who, over the long term, the people who took this test averaged 80 and the standard deviation is 15. If we selected somebody at random, what's the probability that they would score at least 85? And then this is the answer. Or we could ask the following question: over the long term, okay, what would be the proportion of people taking this test who would score better than 85? And the answer would be 36.9% over the long term would score better than 85 on this test. You see, that's another way of interpreting this probability question, because now we're dealing with actual people and people taking tests. All right, so we can ask a proportion, have an interpretation as a proportion. So the proportion of people who scored better than 85 on this test is about 36.9% of them scored better than 85. Okay, and again, let's say we wanted to know what is the what's the probability that if we select somebody at random, they scored less than 70 on this test? So again, we would do normal CDF. Again, it keeps the numbers in as before, so less than 70 means left tail, doesn't it? So if we type in the upper, and now the lower endpoint is negative infinity, so we want to pick something less than, now we know 4 standard deviations, 4 times 15 is 60, 80 minus 60 is 20. Anything less than 20 would be safe to type in as our lower endpoint. Well, let's just type in our negative 1,000, all right? That's certainly well lower than 20. So that because we're used to typing that in. The upper endpoint is going to be 70 because we're asking the probability that x is less than 70. Mean and standard deviation remain the same. So the probability that a person selected at random scores less than 70 is 0.2525. Or we could say that over the long term, about 25.25% of the people would score less than 70 on this test. Okay. All right, let's do another one. Let's say we want to know the probability of somebody scoring between 90 and 65. 90 and 65. Let's select somebody at random. What's the probability they score between those two test scores? Their normal CDF. Well, between 90 and 65, 65 obviously is the lower endpoint. The upper point is 90. Scroll down, hit enter. 58.5859. No, excuse me, 588. What did I mean? 0.5889. So about 58.89% of the people over the long term would score between 65 and 90 on this test, a little over half, right? And then finally, let's do that other type of problem. What's the probability that a person scored less than 55 or scored greater than 85? All right, I want to know the probability that the person scored less than 55 or greater than 85. That's one of those OR questions. So the first one would be less than 55, so that's a left tail. So again, I'll use negative 1,000 for my lower endpoint. And the negatives down here. And then the upper endpoint would be 55. That's less than 55. Scroll down, enter. Then I'm going to put a plus because this is one of those OR questions. What's the probability that they scored greater than 85? So again, I'll repeat the normal CDF. And this time they scored greater than 85, which is a right tail problem. So I'm going to put 85 as the lower endpoint. Positive 1,000 is the upper endpoint. Everything else is the same. Enter. Now I have the sum of those two probabilities in one line, and that hitting enter should give me the total answer, 0.4172. So we could say that over the long term, the proportion of people who scored either less than 55 or greater than 85 is about 41.72%. All right, it's about that percentage of people took the test. All right, so those are, just using this one example here, notice I showed you 4 different types of probability questions. And then if we could do the inverse normal with this also. What if this type of test is for an entrance to a special career? Maybe this is maybe somebody in class here is interested in becoming a police person or working for juvenile courts or whatever it might be. And suppose you have to take this test, and the only way that you'll be considered for this position if you score in the top 10%. The top 10%. All right. So, what is the minimum score on this test for you to be considered for this position? All right, this is a practical question, right? So remember, the mean is 80, standard deviation is 15, and I want to know what's the minimum score that you need to be qualified for this position. And to be qualified for this position, you need to be in the top 10% of people who take this test. So this is an inverse normal question, isn't it? Given the area, now is this the area to the left or to the right if I say top 10%?
Right.
That's right. Now let's see if you understand the idea of percentile. What percentile are we asking for? The area to the right is 10%. What is that percentile that we're trying to find?
0.1.
No. 0.1 means the 10th percentile. If you are scoring, if the upper 10% people, that means what percentage of
be
people scored
0.9.
0.9? If you're in the upper 10%, that means 90% of the people scored less than you, at least 90%, right? So the area here would be, so this is the 90th percentile, right? If you're in the top 10%, that number, what we're trying to find is the 90th percentile for this test. We're going to type in 0.9 here, or 1 minus 0.1, whatever you want to do. Now the mean, again, we want to use is 80, standard deviation 15. Make sure you do that. And the answer you're going to be given here is the actual test score that you need to get, the minimum test score that you need to qualify for this position. You need to score at least a 99. Now, if the scores in this test are in whole numbers, what test score do you need? In other words, everybody who takes this test gets a raw score, which is a whole number. So if 99.223 is your minimum test score, what must be the actual test score that you must get? At least what test score?
A 100.
A 100. That's right. You have to round up, don't you? Because if you scored a 99, you don't make it, do you? No. 99.223 is larger than 99. So if you scored a 99, you're not considered. If you score 100, you are considered. Now, you may not think that's fair, but that's the breakoff point. That's, to be honest with you, government type jobs, that's exactly what they do. They don't play around with this. If they say top 10% and you score just below it, you don't get in. You're not considered. They have to break it off somewhere. So 99 is not counted. 100 is. 100 or higher. Okay, so is everybody clear? You know, in terms of practical interpretation, how this percentile works? Now, in this particular case, I don't think anybody would be interested in the lower 10%, right, of test scores. Certainly, they would definitely not be considered for the job. But you could think of another type of question where you would be interested in the lowest. So for example, if we were looking at racing cars, or I'm just going to make up this example off the top of my head. Suppose that people who raced in a certain type of race, they averaged 100, and when they were at full speed, they averaged, I don't know if this would make any sense, averaged 160 miles per hour. And the standard deviation, so that's your average speed, and the standard deviation will make that 30 miles per hour. All right, this is a racetrack. And we want to know the top 10% in terms of speed. The top 10%, no, this is wrong. This is wrong. This is a bad example. I just realized here, let me give you another example. So let's skip that one. That's not a good example of what I'm trying to find. So what if you're trying to find the time to complete a task? All right, some sort of task. And let's say the average for most people is 100 minutes. And the standard deviation is 8 minutes. All right, so this is time to complete a task. Average 100 minutes, standard deviation is 8 minutes. I want to find the largest time to completion for the people who for the top 10% of people who complete the task. The fastest 10%. The fastest 10%. All right. This is a task where the quicker that you get something done, the better. So I want the top 10% people in terms of time finishing. All right, top 10% in terms of finishing faster. I don't know how else should I say it. The top 10% fastest finishers of the task. So in this case, you would want to know people with the lowest 10%, right, in terms of time, right? Because they would be the fastest. See what I'm saying? I wanted an example like that. So if I said that the top 10% in terms of being the quickest, getting this task done, you would look at the lowest 10% in terms of time, because they would be the fastest. So this would be a left tail test. So I'm looking for the lowest 10%. So how would I do that? Again, I would use inverse normal. Yeah. The lower tail would be the one I'm looking for, the lower 10%. So I'm going to put 0.1 here. The mean, again, is 100. And the standard deviation is 8. So I'm looking for, now suppose, no, this is in minutes. Suppose when we calculate somebody's time to completion, we round it to the nearest minute. We don't have fractions of minutes, all right? So everybody gets their time is always in whole minutes. What we're saying here is that the largest time, where 10% of the times are lower than that, was 89.74. So if you were being considered to be the a group of 10, the 10% of the fastest people, what would be the largest time that you would need to be part of that group of the top 10% of the fastest people? Well, if the times are all in whole minutes, the answer would be 89. You would round down in this case here. Wouldn't that be true? Because 89 point, we're saying that 10% is lower than this, right? So 90 would not qualify. 89 would qualify to be lower than this amount. I hope I was clear with that. I kind of stumbled a little bit, but I hope you understand that if we're dealing with the left tail, then if I'm asking for a whole number, I would ask for the whole number that's less than this number. And a whole number that's greater than this would not qualify. Okay, what percentile, by the way, would this be? In terms of times, this would be the well, it would be the 10th percentile in terms of times, because we're looking for the smallest 10% of times. If you wanted to rephrase it, you'd say the 90th percentile in terms of the fastest times, right? But I would say the 10%, the 10th percentile here would be the correct answer, because we're looking for the smallest 10% of the times. Any questions about that? Okay. So that would be an example where we would be looking at the left tail, where it's a good thing to have smaller values, right? If it's a time to complete something and speed is important, it would be the smallest 10% that would be valuable. And then the other problem that we were looking at before, test scores, obviously, it would be the top 10%, right? It would be the top scores that would be valuable. Okay. I didn't lose you on that one. Let's see if I can find another one here. Number 83. Stop sharing this. And we'll go back to the book. Let's look at another word problem. 83. All right. So it says here, consider babies born in the normal range of 37 to 43 weeks. All right. It suggests that this a normal distribution with a mean of 3,500 grams, standard deviation 600 grams is a reasonable model for the probability distribution of birth weight of a randomly selected full-term baby born in Canada. All right, so this is birth weight. Mean of 3,500, standard deviation 600. The units of measurement are in grams. What's the probability of the birth rate of a randomly selected full-time baby born in Canada exceeds 4,000? So I'm going to ask you, without actually going through the steps, is this left tail or right tail test? And the left tail or right tail problem?
Right tail.
Right tail, right? So we would have the lower endpoint to be 4,000, upper endpoint. Now, would we use 1,000 in this case? Actually, let's do this problem. Let's actually do this problem. Let's do it with a calculator. This is a good example where we have to be careful what we use for endpoints. So let's clear this. Okay. All right. So we're being asked to find a probability. Normal CDF. The question is, okay. Well, actually, we didn't look at the questions, did we? But what are we going to use? Let's go back. And I actually did not show you the rest of the question. So, all right, let's go back. Oh, wait, yeah, we did. We just did. All right, so we want to know the probability it's greater than 4,000. All right, sorry about that. I'm getting a little, need to eat lunch probably. My blood sugar might be low. All right, so anyway. So the question is probability greater than 4,000. 4,000 would be the lower endpoint. This is a right tail. All right, so we're going to type in 4,000 here. What are we going to use for the upper tail? Let's look again at the mean and standard deviation. The mean is 3,500. Standard deviation is 600. Now, once again, use 4 standard deviations to see how far up would you need to go so that the area to the right would be practically 0. So 4 standard deviations higher than the mean. Now, the standard deviation is worth 600 grams. So 4 of those is 2,400 grams. And the mean is 3,500. So if we add those two numbers, it's 5,900 grams. So the upper value here should be at least 5,900. So I'm going to make it 10,000 just to be safe. Certainly don't want to put 1,000 there. Okay. By the way, if I put 1,000 in there, I'm going to get a negative answer for my probability, which, as you know, probabilities can never be negative. All right, so that's how I figured it out. I said, all right, the mean is 3,500. I want to add to that 4 standard deviations. Standard deviations were 600. 4 standard deviations is 2,400. And I add those two numbers, 3,500 and 2,400, I get 5,900. Anything bigger than 5,900 would be safe to put in here. I'm going to put 3,500 for the mean and 600 for the standard deviation. And there's that probability, 0.2023. We could also interpret this as, over the long term, the percentage of newborn babies that in Canada that are over 4,000 grams in weight is about 20.2%. So that's the percentage of those babies over the long term would weigh at least that amount. All right, let's look at the next question. B. What is the probability that the birth weight of a randomly selected full-term baby is between 3,000 and 4,000 grams? Okay. Let's put that into our calculator. between 3,000 and 4,000. Of course, we leave the mean and standard deviation the same. So that's the probability. 0.595. We could say something like, over the long term, the percentage of babies who weigh at birth between 3,000 and 4,000 grams is 59.5%. So that's another interpretation of that one. All right. And let's look at the last one. Whoops. Place there. Sorry about that. Thought I clicked it. Oh, there we go. All right. All right. And the last one says, what is the probability that the birth weight of a randomly selected full-term baby born in Canada is either less than 2,000 or greater than 5,000? This is one of those less than or greater than situations. So we're going to be adding, remember, we're going to add two probabilities together now. Less than 2,000 and greater than 5,000. Okay. Less than 2,000 would be, now, what are we going to put in for our lower endpoint here? Well, once again, the mean is 3,500. Standard deviation is lower than the mean. It's 3,500 minus 2,400. That's about 1,100. So anything lower than 1,100 would do. So in this case, negative 1,000 will work. All right. So put a negative 1,000 here if you want. Okay. And we said it was going to be less than 2,000. So we have to put 2,000 for the upper endpoints. This is our lower tail part of the question. Then we have to do add. We're going to add the second probability. Again, do second normal CDF. This is greater than or greater than 5,000. So we do 5,000 here. And remember, I think we used 10,000 for the upper when we're trying to figure out what number would be okay to put in there. So the area to the right is 0. That's the second part of it. Remember, this is all done in one line. The two probabilities are added together. So I should get my answer. 0.0124. So we'd say something like about 1.2% of all babies born in Canada would weigh either less than 2,000 grams or greater than 5,000 grams. Very small percentage of babies are either going to be too little weight or going to be weighing too much. All right. And let's see if there's anything else I wanted to, yeah, let's look at 785. This will be the last one we'll do as an example. Scroll down to 85. Emissions of nitrogen oxides, which are major constituents of smog, can be modeled using a normal distribution. Let X denote the amount of the pollutant emitted in parts per billion by a randomly selected vehicle. Suppose the distribution of X can be described by a normal distribution with mean of 1.6, standard deviation of 0.4. Remember, this is in parts per billion. A city wants to offer some sort of incentive to get the worst polluters off the road. What emissions levels constitute the worst 10%? This is pollution here. Is this upper tail or lower tail question? That's what I want you to answer.
Lower tail.
Anybody else? Now, obviously, the other answer could be upper tail. Why did you pick lower tail?
Because it said the worst 10%.
And is bad meaning more pollutants or less pollutants? Remember what's being measured here, the amount of pollution. Is more pollution worse or less pollution worse?
More pollution.
So is this a lower tail or upper tail? Remember,
Upper.
X is measuring the amount of the pollution. So if we want to look at the worst polluters, the worst 10% of the polluters, we would be looking at cars that emit more pollution or less pollution.
Or
So is this a lower tail test or an upper tail test?
upper.
Yes. Don't think that upper means best. Upper could mean worst, right? Remember the example I gave you with the time to completion of a task. Remember that one? Upper, in that case, would mean worse, wouldn't it? We want people who are speedy. So the speedier ones would have lower times, and the slow people would have upper time, higher times. You see what I'm saying? In this case here, the worst polluters have the largest 10% of pollution they're emitting, and the ones who are the best vehicles are actually the lower polluters, aren't they? So please don't equate upper with better. It doesn't mean better necessarily. In this case, it means worse. So this is an upper tail test. So what percentile are we being asked to find?
$90.
90 percentile. That's right. So in this case here, we're going to use inverse normal. And for the area, we're going to put in 0.9 for the 90th percentile. We put our mean of 1.6, standard deviation of 0.4, and we'll get that emissions level. All right. Okay. So that's it. Now, we never got to the t-distribution, but I'm thinking, based on what my interaction with you today, that I'm thinking that I will leave the t-distribution to later in the course. And we'll stick strictly with the normal distribution for this test. So let's not talk about the t-distribution yet. We'll talk about that later when the time comes. So basically what I covered today in terms of problems are the types of problems that you will see on the test, next test. And we do have a quiz coming up. The quiz could be a combination of concepts from chapters 6 and 7, and short calculations are also possible. I will put a homework out similar to what we did today for section 7.6, normal distribution homework. I will put that out probably tomorrow afternoon. It'll be due on Sunday. That's Sunday at 11:59. Okay. Make sure you complete that in addition to the homework you have for chapter 6, or for the rest of chapter 7, which is due, I guess, Friday. I believe it's Friday. All right. So there will be another homework number 5. I will put out by tomorrow night, and it will be due by Sunday 11:59. Next Monday will be a review for our second test. Okay. And also a quiz for chapter 6 and 7, and then test number. Our second test will be a week from today, the 31st. Okay. Any questions? All right, and we'll cover chapters 6 and 7. That will be what's covered for the second test. All right, that's it. So if you don't have any more questions, I will turn off the recording, and please watch this recording again. Should be helpful.